Think, Learn, Innovate.
Okay, today's topic we'll discuss is about the transient response of RL circuit with DC input. Is this in your first year basic electrical course? And we'll do the derivation and ultimately we'll find out the response of the system. So first of all, my topic today is transient response of RL circuit with DC input. So first of all, I will draw the circuit. This is an R and L, and I will apply a DC input here. This is my R and this is my L, and the voltage drop across this one is given as VR, and the voltage drop across VL, L is VL, and a current flows through this circuit which is IT, and the voltage input is V. So at first what I will do, I will write down the KVL equation of the circuit is V equal to VR plus VL. So what is VR? VR equal to I into R. And what is my VL? Is equal to I. Uh, sorry. Is VL. What I will write down VL is equal to L, and that is DI of dt. So I'll plug in those values here, and so I got V equal to Ri plus L di of dt. So I will name this equation number 1 and this equation number 2. I will divide both sides of the equation by R, and so what I get here is V by R is equal to I plus L by R into di of dt. So this V by R is the maximum current that flows through the circuit, and I will write down that equation of V by R is equal to a value of I0. So I'll plug this thing here, and my equation becomes I0 equals to I plus L by R, and what I get di by dt. So I will take this I0 this side and this one that side, so I get minus L by R di by dt, which is equal to I minus I naught, and that equation gives me equation number 3. So as I got this equation, what we will do is we'll go to the next page, and what we'll do here is I will try to solve that equation. So I can write down this equation in this format: di divided by I minus I0 is equal to minus R by L into dt. I'll do an integration. Now remember one thing, the circuit is at first is T energized state. So at T equal to 0, what is the current flowing through the circuit is 0. When I plug in the value at T, what will the current flowing through here? And I will name it to be I of T. So that's my limit of integrations. And if I do this integration, what I get ln I minus I0, which is equal to minus R by L T. And the cost limits are 0 till it, and here is 0 to t, so there is to be minus R by Lt. So if I plug in the values of this one, what I get ln, first I will plug in the value of it here, so I got it minus I0 minus ln minus I0 equal to minus R by Lt. So it's log A minus log B, so I get ln it minus I0 divided by minus I0 is equal to minus R by L t. So if I do this thing, what I get is IT minus I0 minus of I0 is equal to e to the power minus R by L, R by L and t here. This is, always remember, this is not t, but this will be R by L into t. Now if I do here, so what I get here, so if I do that, I get IT equal to I0. See, this I0 will come this side and I will multiply this I0 with this one. So I get I0 minus I0 e to the power minus R by L t. So if I take the I0 common, so what I get here is IT. The current flowing through the circuit at time t is nothing but I0 1 minus e to the power minus R by L t. So that's my value of current which is flowing through the circuit at time interval t. So this is my equation number, final equation number 3. Now what we have to do is we have to find out the voltage across resistance and the voltage across the reactance. So next topic which I will do is I will find out the voltage across all the values voltage. So first of all I will find out, here I will find out voltage, say voltage across resistance. So that gives me VR at time t gives me IT into R. This IT is nothing else. So VR of t is equal to, what is IT? The current which I got now, that is V by R 1 minus e to the power minus R by LT into R, and that's R goes away. So I got my V of R of t is nothing else. What I got? V 1 minus e to the power minus R by L t. So I got the values of my voltage across the resistance. My next topic is to find out the voltage across the inductance actually. And what I got, that is very easy. I got it VL of t is equal to L d IT by dt. And I know what is my IT. So I got L d of dt. I will plug in the value of IT, which is V by R 1 minus e to the power minus R by LT. And so if I do this, see, if I do this derivative, the derivative of 1 is 0. And if I do the derivative of this equation, what I get is minus R by L. And this minus and minus gives me plus. So what I got here is VL of t, which is equal to L into R by L. The minus minus goes away. Minus R by L. So this L and this L goes away. And I have here another V by R, which is this factor. And so V R goes away. So my voltage across inductance is very easy. And that nothing else. That gives me V e to the power minus R by LT. Okay, so this is the voltage across resistance, voltage across inductance at any time interval t. From this equation, we actually you know that the time period, the time sorry the well, we will come here and we'll say, okay, the time constant of the circuit, always remember the time constant of RL circuit is always remember is L this RL circuit, the time constant of RL circuit, which is given by T equal to L by R. This is a very important question. All the time people ask you this question. So what I will do next is I will find out the values of current and voltage at this time T. So I will find out the current IT, which is at L by R. So what I will get? I0 1 minus e to the power minus R by L, and my T is L by R. So if I cos this one, what I get? 1 minus e to the power minus 1, and that gives me I0 1 minus 0.368, and that gives me 632 I naught. Similarly, I can find out the voltage across a resistance, that is L by R. So that voltage is V 1 minus e to the power minus R by L into L by R. And this R goes away, L goes away. And so I got V 1 minus e to the power minus 1. That gives me V 1 minus 0.368, and that gives me 0.632 V naught V. So if this is my value of voltage across R, so similarly I can find out the voltage across inductance and L by R. What I get? V e to the power minus R by L and L by R. That gives me V e to the power minus 1. That gives me 0. So we can state here that at time constant is that value at which the circuit voltage build-up takes place, around 63% of voltage build-up takes place, and the current across the circuit becomes 63.2%. If I want to draw the characteristics of this equation, this circuit actually, so if I draw a characteristics voltage across, this is my voltage across R versus T, I can draw another characteristics, that is my voltage across inductance versus T, and I can draw the current build-up circuit in this transformation, and that is V current IT versus T. So these are all as a function of T, so I would better write down the function of T. So if you look at the current equation here, is when the exponential term becomes 0, t equals 0, e to the power 0, so 1 minus 0, 0. So it will have an exponential curve like this, and at a certain interval of time, it becomes steady. So this time when it's varying, this is called the transient state. And this is my steady state, where the voltage and current become constant. This is my, say, T equal to L by R, where it gives me how much? 0.632 I naught. Similarly, if I come to the voltage, same equation, so it will go up, build up, and again, it will be a straight line. This is my transient state, and this is my steady state, so I will like steady state. Steady state is the state where voltage and current with respect to time become constant, and transient state is called a variable state where voltage and current varies with time. It is called transient state. Similarly, at T equal to L by R, what I get? 0.632 V. And if you see VL, it's the, whenever the I becomes infinity, it becomes 0. So it comes out and it draws at a certain time, it becomes 0. So from these characteristics, we can state that at steady state, the voltage across inductance becomes 0, and the current flowing through the circuit is maximum current, that is V minus V by I0. And another thing which we can say overallly is that at steady state, when I apply a DC voltage to an RL circuit, what happens is that the L circuit becomes short circuited, and so the voltage drop across a short circuit is zero. So at a steady state, the VL becomes zero. Thank you. I hope you like my video, and so I will bring another video pretty soon. Bye.